All right, is it big enough? Everyone can see? All right, let's get started. So I'm going to talk about microservices today. So how many people here are working on web services and stuff like that? Please raise your hand. All right, cool. So the talk is going to be a little bit short, so maybe I won't be able to present everything I wanted to present about microservice. But it's okay, I wrote a book about it, so if you want to get the book, everything is in the book. So who am I? I work for Mozilla from France, remotely, and I've been working at Mozilla for almost 8 years now. And throughout my time at Mozilla, when I joined Mozilla at first, they wanted to move all their PHP web service to Python back in 2007. Because in 2007 it was cool to move from PHP to Python because we had Django, we had new stuff coming, and they were really excited about the features in those frameworks. So we started to move each service in this new language, and I had the chance to be the first Python guy around, and I had the chance to set up the Python ecosystem at Mozilla for building web services. So that was really cool. And we built many, many, many web services. How many people here use Firefox? All right. And Chrome? And both? OK, cool. So when you use Firefox, if you synchronize your bookmarks to another device, it's going to call a web service, which is written in Python called Firefox Sync. And we have many little web services like that will make your browser work if you have some data on the server side. And these days, I'm not working on that anymore. I'm moved to the dark side. I'm working inside Firefox to do some performance work in C++. So that's when I realized I really love Python. All right, so why this topic? Maybe a year ago or so, I was approached by Pact to write a book about microservices. And I was like, no, I'm not going to write a book about microservices. This is just a buzzword. That doesn't mean nothing. When you write services, you just write services. I've never used before the micro prefix to describe a service. So I didn't know what to say about it, and they kept asking and sending email, and I started to try to reconsider it and see if there were a topic around microservice, because we've done a lot of services at Mozilla, and eventually I realized that all this time we were in fact doing microservices. So I said, okay, I'm going to write a book about microservices, and because Python is really a sweet language to write microservices. And so the first thing that's important is to give a good definition about what are microservices. And this is my attempt. It's a little bit long, but I think on this slide you have a pretty good definition of what's a microservice. It's a standalone, very small application that focuses on doing a single thing. It's not an app that's trying to provide a bunch of features, just one feature and one feature alone. And with that well-defined contract is going to be interacting with other microservices to provide a full application. And it's important to keep that in mind when you create microservices. You want this service, this component, to be independent from the other one, and you want your team to be able to deploy microservices independently from other people. So if you have, I don't know, a booking service, it has its own release cycle, it has its own development cycle and tool and whatever you use to build this service, and it should be independent from the rest. So that's the idea behind microservices. Instead of having a big monolithic application, you split it in smaller pieces that interact with each other. So that brings a lot of benefits. So separation of concerns. If you have a team that works on a service that books train tickets, they're going to focus on that feature and they're not going to worry about anything else. And they will be able to make this service evolve independently from the rest of the application. So that's really a benefit in terms of design. It's smaller projects, so it's easier to iterate fast and to have a release cycle that's not blocked into a big project. We had in the past at Mozilla problems with that. For example, the addons.mozilla.org is a huge Django application, and every time someone was doing a little change in the application, they had to go through a very heavy and process to have the feature deployed eventually in production. With the introduction of microservices, they were able to release stuff faster. For example, we introduced at some point in our marketplace for the now dead Firefox OS phone, a service to introduce payments, and the people that created this service started to do it within the Django application, and eventually they moved it to a microservice, and they were able to just to iterate faster. And you have more scaling and deployment options. If I take back this example from the marketplace, if you're able to deploy a single feature independently from the rest, and if it needs to scale and if it takes a lot of requests per second, you're going to be able to deploy like, I don't know, 10 instances of these microservices independently from the front end that will interact with it. That's basically it. The problem is when you start to do microservices, there are a lot of risk and a lot of pitfalls, and it's really easy to do a crappy application with microservices. Bad design decision. Hey, this feature, it should be a microservices. Yeah, let's do it. And then 6 months after, oh, crap, everything is broken. Every time I'm changing this microservice, I need to change this other microservice, and we need to deploy this other stuff. And eventually, instead of having a big monolithic application that sucks, you have 10 small applications that sucks, and it's worse. So it's easy to make bad design decision, because that's we're doing bad decisions every day, and the core thing of our work is to fix our bad decisions. Network overhead, of course, if you start to add little microservices all over the place, you need them to interact with each other, and that can add some overhead. Sometimes it's cool because you're doing some stuff synchronously, but most of the time, in some cases, it's just going to make things slower and heavier, and you're going to add single points of failure all over the place. Testing is harder because now you have to deal with many moving parts. So if you want to test your application as a whole, it's harder. And when you need to share data between your microservices, that's also a big problem. For example, if you have a user and the user is defined with an ID in one microservice, what happens if you want to deal with that same user in another service? Are you going to have the same ID in a database with the auto-increment? Are you going to use an email? Problems like that. And last but not least, if you're going to make each microservice evolve independently, and what does that mean for the consumer of your microservice? Are you able to do things in a way that's going to be backward compatible, or are you going to break everything and having to deploy other microservices around? So that brings a lot of problems. But there are a few key principles you can use to build microservices that are still useful. The first one, don't try to make microservices when you start your application. You don't create microservices on day one. It should happen over time. You create an application, and at some point you realize eventually that this feature in your application could be a separate microservice because it's going to be easier for your team to deal with the release cycle independently. It's going to provide more ways to deploy some stuff. But you can't find out about that when you start building your application. You should wait and make it happen naturally. Second rule, premature splitting is the root of all evil, which means if you decide to split part of your application as a microservice and it turns out it's a byte ID, you're going to be in a place where it's going to take maybe a month to get back to the better design. And like when you are doing some optimization in your code, if you try to make your application faster without the need for it to be faster, you're going to be in trouble. And that's the same for microservice. Don't add microservice just for the heck of it. You need to add them because it makes sense. So don't split on day 2. Avoid building CRUD microservices. So CRUD is basically when you create an API that's very tied to your data, like create, read, update, and delete. For example, if you have a database with people, and you start to create an API that will let you create, read, update people. If your API is very close to your database, every time you're going to change your database, you're going to impact your API, and it's going to be harder to make something that's backward compatible or something that will not impact other services when you change your database. So the idea behind this rule is if you have some data, try to keep them internal to your service, and then try to create an API that provides a feature that is not a full reflection of the data that's in your microservice. And rule number 4, use standard protocols. I mean, don't try to create a cool low TCP or UDP microservice that's, I don't know, sending your cool new serial binary format to read and write data. I mean, all those stuff are really interesting, but when you start to write a microservice, you should use standard stuff, mature protocols, and then eventually, if you need it, you can like change it after a little bit of time. But it's important to stick with standard protocol. And building microservices is just building HTTP service. And I mean, at Mozilla, we've done services using like fancy binary protocols. Really cool HTTP2 stuff or low-level socket interaction. But at the end of the day, if your service is using HTTP1 and sending back and forth some JSON, it's the best way to go because that's something that's easy for other people to interact with. It's a known standard, and most of the time, it's good enough for what you're going to do because it's not how you send and receive data or how you serve data that's going to make your stuff fast or slow. It's what you're going to do with it underneath. And we're trying to do RESTful design. So I'm not saying REST, like pure REST, but just RESTful, like something that makes sense when you read the URLs. So using the HTTP verbs as actions and trying to reflect the feature in our URLs, and with version numbers. There are also some cool tools in the community to write microservices that follow some standards. You have Swagger. So Swagger is a way for you to define your service in a JSON description. It's a little bit like WSDL back in the old days. You also have JSON schema, which will allow you to verify that the data that comes in and out is valid. And to do all the authentication, you can use the auth to dance. That's the standard. and exchange a small JSON object to verify that user is allowed to do whatever they want to do. All right, designing HTTP API. So like I said previously, you should version your API. You should try not to surface too many details. Okay, and if you can keep things backward compatible, it's better. When we wrote the first version of Firefox Sync, we really thought it was the end of the story. Hey, it's super easy. This is how you store your bookmarks, / bookmarks, whatever. That's cool. It's not going to ever change. And then we had to change it. And we worked on the version 2 of the protocol, and we tried hard to find something that was backward compatible, and we failed. So we were with Firefox Sync 2 and Sync 1, and we were like, okay, so we have like millions of users for Firefox 1, Sync 1, and we need to move them to the new version. So how are we going to do that? And we started the nightmare that lasted for, I think, 2 years. Just to move people from the old version to the new version. Just because my mother uses Firefox once a month. And when she's going to start Firefox again, she's going to be on the old client. And I want to move her to the new API. And I want it to happen transparently for her. And that opens a cans of worms. And it's awful. So if you can keep your API backward compatible, it's better. And that brings back to the don't design stuff like CRUD, because that's going to make things harder. And like I said, JSON schema that can really help you to do a good job in your data definitions. Framework. So there are so many frameworks in Python to do some web. I mean, all of them are super cool. I really enjoyed Bottles. Bottle is like one of the framework that existed before Flask, and I think Armin used Flask for his framework because of Bottle. Twisted is really cool. It's async, but it's a little bit over-engineered sometimes just to build microservices. And Tornado is super cool. And Flask, AO, HTTP, and put the name of your favorite framework there. As long as you can read HTTP requests and send back HTTP response, it's good enough to do some microservices. But my two favorites are Flask, because it's a mature framework. It has a really rich ecosystem. Basically, when you write a web service using a Flask, you can find anything and everything in the community to do something. And AO HTTP, because it's asynchronous, and it uses the little Python 3 version. So you can use like async, await keywords and stuff like that. So that's really cool. And we tend to move from Flask to AO HTTP, and I think now when we start a new project, we tend to only use AO HTTP because I guess the only difference is that one will be able to handle one request at a time, while the other one will be able to handle many concurrent users at the same time. I mean, with Flask, you can't really deploy it in a way where you can handle a lot of simultaneous connections. Most of the time, it's not an issue, but at Mozilla, if we have a service that needs to handle a lot of connection, it's better to go async. So, and async in Python rocks, so why not? All right, so I wrote a book about microservices, and I wrote a case study to explain how we could write microservices. And I'm a runner, and I use Strava. How many people here know Strava? Okay, so Strava is a platform where you can, like, you go for a run or a bike, a ride, And when you're back home, it's gonna show you run on a map, and you can like show off and tell your friend, hey, I run faster than you. And you have some graphs and stuff like that. And so this app is just interacting with Strava and provided a dashboard with extra feature, like, hey, this is the list of the races I want to do. This is training plans and stuff like that. It's just a case study for building microservices. It's not like a real-life app, but it was a good way to explain how you could build a microservices-based application. And each square here is a Flask application, dashboard, data service, race, training plans, and token dealer. And the app is composed of all those microservices that interact with each other. And there are two Celery workers. So Celery, how many people know Celery here? All right, Celery is a tool in Python that you can use to send some work to a background worker. So basically here, the data service microservice asks the Strava Celery worker to interact with Celery, do some stuff, and feed the database with it. So building a microservices with Flask is dead easy. This is a microservice. It doesn't do much, but it's a full web application that works. Here, in a few lines, I've created a web service. I plugged a URL, API v1 foo, and this, when I call it, is going to return a very, very interesting JSON blob containing a key and a value. And basically, all the services we're building are starting like that and just growing a little bit, adding calls to the database and stuff like that. And the biggest thing about writing microservices is messaging. You want your microservice to interact with other microservices or with Celery workers or stuff like that. And there are three ways to interact with another microservice. A push-pull, where one microservice is going to interact with many other ones to ask them to do some work. A publish-subscribe microservice is going to say something, hey, this happened, and other, oh, interesting. And a direct call, one microservice call another microservice. Like, for example, hey, this user wants to connect. I'm not sure if it's allowed. And then you call the microservice that is doing the authentication. And it sends back a token, say, yeah, he's allowed, and then you can use the token. So it's a direct one-to-one call. So how do you do that in Python? So to do a push-pull is super easy. This is a full Python application and using Celery. And in fact, this is a microservice. I can write microservices with Celery. This is a worker that is going to fetch data on Strava, and it plugs a Celery task, and is going to interact with Redis to take some orders. And in Redis, it's going to block on a list and wait for people to send some work to do. That's a microservice. And I can run it with Celery, and I can run several instances of this microservice to wait for some orders. So that's my workers behind another microservice, and it's a push-pull pattern that's super useful to do some processing asynchronously. And on the other side, in my service that wants to grab some data, I can just send the task to Celery through one call here, and this is going to add a line in Redis and just ask the worker the first worker that's going to pick it up is going to do some work. It's a round-robin principle. Yeah, so push-pull, super simple. Celery is using, if you want to, when you use Celery, it can use Redis, but it can also use RabbitMQ as a backend. And in fact, Celery is just a subset of a full messaging system. And Rabbit, if you want to do other pattern like publish and subscribe, you need to move to RabbitMQ, for example. There are other implementation, but RabbitMQ is Python friendly. They are a good lib. And RabbitMQ can do much more things than Celery. to do a push-pull with RabbitMQ, sorry, a pub/sub. Here, this is also a full program that's going to send a message just to tell anyone that's interested about it that there is a new report number 2 ready. And you can send to all your microservice a message like that using the pk lib, which is going basically to interact with the RabbitMQ broker and iterate. Oh, 10 minutes left. Okay. Iterate just to send a message all over the place. All right. And to consume RabbitMQ events in your microservice, if you're in an async framework, it's super easy. You just add a new callback in your event loop and interact with your RabbitMQ queues and just see if there are new message. If you're in a sync framework, it's a little bit harder if you want to do it. You can use a plugin in RabbitMQ that's pushing JSON blobs to your microservice given an endpoint. The problem is, when you do that, if there is something wrong, and there are always something wrong when there is some network, you cannot do your own programming easily within the RabbitMQ plugin. So it's best to write your own bridge between RabbitMQ and your microservices and create a small RabbitMQ to HTTP API bridge where every time a message arrives in RabbitMQ, you're going to do the work to send it to the people that's interested, to the services that are interested. So this is how you write a bridge. You can use a blocking connection in pk, and every time something shows up in RabbitMQ, you can call the OnMessage here function and do whatever you want. And here, every time I get a message, I'm going to use the requests library to send the RabbitMQ message to that microservice. And if it's a success, I'm going to hack RabbitMQ and tell it, okay, I was able to send the message through. So this is how you plug microservices around RabbitMQ. And the last way to do messaging is direct call. So if you're in a sync environment and you can use requests. And if you're in an async framework, you can use AU HTTP client and do some callbacks. All right, authentication. When a service receives a call from another service that needs to be protected, you need to set up some authentication. In order to do this, you can create a dedicated microservice that is going to provide tokens that can be used to do the authentication. So here, service 1 wants to connect to service 2, but service 2 will say, if you don't have a token, you can't have the candy. So service 1 is going to ask the token dealer, hey, I want some candies from service 2. And the token dealer is going to make the decision, yes, okay, you can have some candies from service 2. Here is the key to the candy box. So it's going to send a key to service 1, and then service 1 will be able to do the interaction. It's a little bit like OAuth, but it allows you to create authentication between service instead of humans. And basically, you get a key, and you can use the key to interact with another service. And to do that, we use a standard called JSON Web Token, JWT, which is basically a JSON blob containing information about whether the user is allowed to do this or that. You can add many information in that token. You can say, hey, this user is allowed to read but not write this information, stuff like that. It's signed by the token dealer, so it's protected. It uses you can use public-private keys, which means it's easy to deploy a token-based authentication system with microservices without having to give people passwords. You just publish your public key, and any microservice can ask for a token using that public key. And to check if a token is valid, you have libs in Python to do that. There is JWT. I think it was written by a guy from Mozilla, where it's going to look at the token you're going to put in the authorization header, and just verify that you're allowed to do whatever you want to do. And I think I'm going to run out of time, but I'm going to say a few words about testing. Testing is super hard. It's probably one of the things that's the hardest to do when you build microservices, because when you start to have a lot of moving parts, it's very important to be able to test your app as a whole. And if you're not able to do that, you're going to run into trouble. So you need to make sure that you have a reproducible environment where you can deploy your app in order to test it as a whole. Of course, you want to test your microservices independently. For that, you can use some mock when the microservice call another microservice. And you can use tools like web test if you want to do some testing, functional tests, or Molotov to do some load testing. Deploying, so you need, when you do a simple application, it's really important, but when you do a microservices, it's way more important. You have to CI everything. You have to make sure that every time something changes, you push it to a new dev environment, you deploy all the microservices, and you make sure that all the interaction works. Because if you don't do that, you're going to have some surprises the day you push in production. Docker. So Docker is pretty cool to deploy microservices because it's easy to just push Docker in whatever cloud system you're using, if you use a cloud system. And if you deploy on Amazon, they have tools to make it even easier. Now with the latest Amazon web services, if you have a Docker image, they can deploy it using CloudFront very easily. Monitoring, debugging. It's important to see what's going on in your microservices. We use TADDog, for example, on Amazon to get real-time feedback of what's going on in the environment. But it's not open source, and there are other great tools out there. So there is Sentry that's very Python friendly. It's going to be able to provide you some information about the tracebacks you get in your application. But it's very specialized for that. If you want a tool that's doing more stuff, if you want a tool that's able to oversee everything that's happening in your microservices environment, I really suggest you look at Graylog. Graylog is super powerful. It allows you to create an environment where you can see what's going on in terms of performances, to grab all your logs and all your traceback, all in the same dashboard, and it's open source and it's easy to deploy. I think it's using Elasticsearch. Conclusion. So if you want to write microservices, Python is perfect for that. Don't use C++ to write microservices. C++ is fine. I'm not going to bash C++. Just a little bit. It's one of the best ecosystem. Python, if you go to PyPI, there are many tools to do your work. But be super careful. Don't try to create microservices just for the heck of it. Make sure that it makes sense in your application. And really, if your application works, it's better not to touch it. A good old application usually is better than crappy microservices. I think that's it. So if you're interested in the topic, I wrote a book that is explaining everything I explained in 40 minutes, but in more pages. So thank you.
Thank you for great introduction to microservices world. Now we have time for some questions.
Okay. So first of all, thanks for the presentation.
Thanks.
And the first question is, what's your approach towards the development environment? So from what I've seen from my experience, people tend to build the full copy of the production system with the help of Docker, Docker Compose, or Kubernetes, and it seems to, be juxtaposed to the approach microservice architecture seems to provide. Just because you have a microservice, it has a contract and should be tested in isolation. So as a part of the development team, you should be able to just have a copy of a working microservice. You have to test against the contract, and that's it. But in the real world, from what I've seen, you have to have the whole copy of the system just to test the feature that requires the interaction of multiple services. So that's the first question.
Yes. So I think several tools can help there, and several good practice can help. I think a microservice should scale down. You should be able to deploy your microservices on maybe a SQLite database, and you should, as a developer, be able to run the whole system with all your microservices on your development environment. Where you could use, the Docker tools, for example, that will allow you to create the Docker Compose, or whatever tool you use to deploy locally. You should be able to run the whole system to do the testing, like you said, as a whole. It's important, because if you don't do that, you get into trouble when you push stuff in production. Maybe it's not the same person. If it's a big company, maybe you as a microservice developer, you just deal with a microservice, and then you give it to another team that's in charge of testing the whole stuff. That's sometimes people do that. And also, if you have a good CI system, maybe you don't even have to do that on your own laptop. We have some projects where every time we deploy a new microservice, we have a dev environment on Amazon that gets updated, so we can do our testing there. So that's a good. It takes time to do it. It's a lot of work, but once it works, it's magic, because it means you can even add some hooks on GitHub, for example, to get your dev environment on Amazon updated. So I would say, depending on the size of your company and the time you have to do some CI, those are all the options you can take to do some testing.
Okay, so the next question is, you mentioned end-to-end testing in one of your previous slides. So how do you approach that? Do you have a copy of, production and a set of, like JavaScript or Python tests running against that environment? Or what's the approach?
Sure. So it depends on the application, of course. For example, in our case, we do a lot of web services, so we don't have the JavaScript side. And our QA teams wrote what we call small smoke tests. It's a simple Python script that interacts with the full system and makes sure that everything works as expected. For example, we have some script that tests sync, Firefox sync, by grabbing an authentication token to a service and just make sure that the whole cycle works. So the approach, I guess, is to make sure that you have a functional test that interacts with the service and make sure that everything works without looking into each microservices independently.
Oh, sorry. Can I?
Okay, so thank you for the presentation.
Thank you.
Also, two short questions. So the first is, what's your opinion about using gRPC instead of REST?
Yeah.
And the second is regarding to when you actually should switch to microservices. You raised a couple of very, very valid points about when you should not, but when you should.
Yeah, okay. So for the first question, gRPC, I don't have a lot of experience with it. I know it exists. It looks like a cool standard, but for the work we're doing, using a plain REST and JSON seem good enough, and we don't feel like we needed to go to a full standard like that. Maybe we should. For the second question, so you ask, can you? What are the good reasons to move?
Yes.
Okay, so we have at Mozilla a big Django application. Django is great, but it's also easy to grow them as monsters. And we had a few monsters in the closet at Mozilla. and people were trying to change tiny little stuff in the payment system, for example. And every time they changed one line of Python, they had to run 3 hours of test just for that. And now they took this payment system, made it a microservice, and magically their life was easier again. They were not depressed anymore because they could do like small release cycle. The tests were fast, and they didn't have to depend on the huge Django application just for 2 or 3 Python function to do some payment. So that's where it makes sense to split this feature out of a big application.
Yeah, so maybe a couple of indicators. When you see this or this is happening, you should think of migrating to more microservices.
Is the feature, the payment, can be useful to others' applications? Can the feature evolve independently from the rest? Can I write it in another language? If I change the way payment works, can I keep the same API and it's still going to work? Like, for example, I use, payment provider 1. When I go to payment provider 2, can I keep a generic API on the top of it and nothing is going to break on other consumers? Stuff like that.
Thank you. Thank you.
Okay, I have one question, quick here. Thank you for a talk.
Where?
I'm here.
Yes,
sorry.
Oh, sorry.
Could you please share your experience about the different side, about showstoppers, when we definitely shouldn't go to the microservices way? For example, some teams have pretty precious monolithic and they are struggling with it and they want to split it in microservices, but sometimes it's a bad idea because you don't need, I think, for example, you don't need microservice just for sake to having just one another HTTP bridge to your database, as you said, and maybe something more interesting when not just you need to share data between your services, but maybe something more interesting. Thank you.
Yeah, so you raised a very valid point. You shouldn't share a database between microservices. A microservice has its own database, and it's independent. If every time you change the database, it's impacting several microservices, it means it's wrong. It should be a single application. A microservice shouldn't see the database of another microservice. And that's one of the points where you can see if it makes sense to have microservices. If you have a database and an application on the top of it, and if you're like, I should split this off this database, and you're not able to create a separate database, it means you shouldn't break it as a separate microservice. It should be isolated fully. It should be 2 different apps. Of course, sometimes you need to share some data, and you need some like convention, like how I'm dealing with the user ID, or this is a product. Should I use like a product ID? Is it going to be the same between the 2 databases? Stuff like that. That's inevitable questions, but it should be separated database. So that's a good indication if you want to create a microservice. Am I able to do this, or do I need, every time I change the database, to redeploy 3 microservices?
Okay, thank you. Unfortunately, we don't have time for more questions, but I suggest you to...
Yeah, I'll be around if you have questions.
Just ask them offline. So now we have small coffee break. Also, please note that we have second track in room near this room. Yeah.
Thank you.